Hi and Assalamualaikum. In today's video, our group will be present about one of application of differentiation, which is related rates. But firstly, let me introduce our group members. First, we have Amirul Zuhairin, which is me, Damia Maisara, next is Fatia Husna, and lastly is Nur Batisha Balkis. So, let's start it. What is differentiation? Differentiation is a process of finding the derivative or rate of change of a function. Why we need to use differentiation? To determine the maximum and minimum value of particular function. There are three techniques to solve the differentiation problem. Firstly, derivative of sum and difference. Next, derivative of product function, which is called the product rule. And lastly, derivative of rational function, which is called the quotient rule. The rate of function is defined as dy over dx equals to fx equals to 1.
Next, we are going to talk about related rates. So, what is related rates? Related rates are rates of change associated with two or more related quantities that are changing over time. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time. Implicit differentiation is often used. So, why we use related rates? We use related rates to understand how different variables influence each other. Other than that, related rates also helps in analyzing and modeling real-world scenarios involving motion, growth, and other time-dependent processes. And lastly, how to solve questions about related rates. First, we identify what the two variables are. Next, we find an equation relating to them. And lastly, we solve for the unknown rate using implicit or chain rule.
Next, I'm going to explain about the problem statement and what to solve, and also problem solution, how to solve, and I'm going to show you the word solutions. As you can see in the video, this is example 9. What is the problem statement? The problem statement is a manufacturer wants to design an open box that has a square base and a surface area of 144 square centimeters. Based on the picture, you can see this is the box and the box has an opening at the top. So the first question is prove the formula of volume. The second one is find the dimensions of the box such that the volume is maximum. And the third one is determine the maximum volume. Firstly, I'm going to show solutions for the first question, which is proving the volume of formula. So as we know, the actual formula of volume is volume equal to length multiplied with V and multiplied with length. So based on our picture, our width is x and our length is x2, which means our width and length has the same value. Meanwhile, our height is y. So based on our chosen question, volume equal to x multiplied with x and multiplied with y, and we will get v equal to x squared y.
Next, I'm going to explain about question number 2. So for question number 2, they are asking for find the dimension of the box such that the volume is maximum. So in order to solve this question, the first step is to write the formula for volume of cuboid. So actually the volume formula of cuboid is height times width time length. So the formula that we will get is actually v equals to x squared y. And then the second step is to express x in terms of y. So given the surface area equals to 144, and then we will write the area for cuboid. So we will get x squared plus 4xy equals to 144. So the x squared is because we have a bottom only, which is x equal x times x, and then for xy because we have 4 sides of them. This is 1, this is 2, this is 3, and at the back is the 4th one. And then we make it the y is single, so it will become y equals to 144 minus x squared over 4x. And then the third step is to substitute y in the volume formula. So v equals to x square y, substitute the formula, and then we will get 144x square over 4x minus x to the power of 4 over 4x. And then because all the terms have x, we can eliminate it. After we eliminate it, we will get 144x minus x to the power of 3 over 4. And then the final answer will be equals to 36x minus 1 over 4 to the power x to the power of 3. So next is to find the derivative. So in order to find the derivative, we are going to differentiate the answer from the step number 3. So v equals to 36x minus 1 over 4 x to the power of 3, and then when we differentiate, it will become dv over dx equals to 36 because actually 36x have power of 1, so we will minus 1 and then we will get 36 only, and then minus 3 over 4 x squared because 1 over 4 will multiply with 3, and then the x to the power of 3 will minus with 1, so it will become 3 over 4 x squared. And then the step number 4 is to let the derivative equal to 0. So 36 minus 3 over 4 x squared will equal to 0. And then we change the position that for the terms that have x, so it will become 36 equals to 3 over 4 x squared. And then we will multiply 36 with 4, and then we will get 144 and equals to 3x squared, and then 144 will divide with 3, and then we got 48 equals to x squared, and then x will equals to square root 48 cm. And then the last step is to do the second derivative test. We will differentiate it again. So d square v equals to 0 minus 3 over 2x, and then we differentiate, it will become negative 3 over 2x, and then when x equal to square root of 48, the answer from the step number 5, and then we will substitute in this formula, so it will become d square v over dx square equals to minus 3 over 2. Substitute it, so it will times with square root of 48, and then we will get answer negative 10.39. So bear in mind that if we do the second derivative test, so if the answer is more than 0, so it is a minimum value, but if the answer is less than 0, it will become maximum value. So in this case, we can define that so x equal to square root of 48 cm is a maximum value. So when it is a maximum value, the answer that we got, which is x equal to square root of 48, we will substitute into the formula, the volume formula of cuboids. So it will become y equals to 144 minus square root of 48 to the power of 2 over divide with 4 times square root of 48, and then the last answer will become 3.46 cm. That's all.
Lastly, I'm going to show solutions for our third question, which is determining the maximum value. Based on question 2, we obtained that x equal to square root 48 cm and y equal to 3.46 cm. So we are going to insert our values into our volume formula, which we had discussed on the first question, v equal to x squared y. By inserting x and y, we can determine the maximum value. So v max equal to square root 48 square and multiply 3.46. This is x and this is y. And the final answer will be 166.08 cubic centimeters. So that's all for our discussion based on our questions.
So, in conclusion, by using differentiation method for this problem, we can conclude that differentiation can be applied to determine the value of a volume, solve real-life problems involving volume, and address issues related to the value of a volume.